Right. Okay. Well, thanks for taking the test last week. You'll get feedback soon. But we're now focusing on the next part of the module. So the tunneling, SSL, digital certificates, cryptocurrencies, and then next week we'll be looking at some future crypto. Those will be the focus for the next part. So we have about 6 or 7 weeks to get ourselves together, look at the coursework. So please have a look at the coursework in the next week or so and be comfortable. Don't bite off too much. This isn't a dissertation, it's a piece of coursework. It's a bit of lightweight crypto, a bit of evaluation, a bit of lit review, and it isn't a 50-page dissertation. So don't get too hooked on it. If you want to take it forward to your dissertation, that's great. At least lay down the groundwork. Okay, so I'll try and get you a lecture online that goes over the coursework, what a good output would look like. I use Overleaf, and you don't have to use that, but it certainly makes it easier to write a research paper. So we've got 40% for the coursework and 30% for the next test, and that gives us all our marks. By the time you get to test 2, you kind of know where you are and how much work that you need to put in to the test. Does anybody have any questions on what's next and what you need to do? So I'll go over the coursework in more detail in another class. For today, we're looking at an extremely important area, and that's blockchain and cryptocurrencies. The internet we've created was born in the 1980s, and it's still basically the same. All of the stuff that happens is still based on a lot of what we created around the 1970s and 1980s. The trustworthiness of this digital world that we've created is almost zero. You cannot trust any email that you receive as to the sender. You cannot trust that anybody has read that email, and you cannot trust that anybody has changed that email at all. So we've built up a data infrastructure where trust and security are add-ons, and it doesn't quite work. Blockchain and cryptocurrencies look at changing that world and building in digital trust from the core. At the core of this is digital signing. That every transaction that you make is signed by your private key. And that key is yours and no one else's. It's your identity, and everything can be proven. The email can be proven to come from you. The email can be secured for you with your private key. Lose that private key and you're in big trouble. So we're going to have a look at the core of this. And I don't care what we call it, a distributed ledger, a blockchain, a Byzantine fault-tolerant network, it doesn't matter to me. And if we can get over the hype, and people say, well, it's all to do with Bitcoin. It's nothing to do with Bitcoin. Bitcoin is like the fourth T of blockchain. It just happened. It was the first one, and it's still running. It's been highly successful, but it's extremely flawed in virtually all of its operation. But we've managed to fix a speeding car to make it go faster. So Bitcoin's a bit like you're going along a motorway at 70 miles an hour, and you're getting an upgrade for the engine to make it go at 200 miles an hour, and you're not allowed to stop it. You've got to fix it as it goes along. So that's where we are, and we're basically prototyping a new world. So when I get asked about blockchain, I say that it's all about that. Oh, that shouldn't have appeared. So what's that? It's a Merkle tree. So it's a Merkle tree. At the core of blockchain is Ralph Merkel's tree. a genius researcher who, even when he was an undergraduate, was inventing new public key methods. He came up with a Merkle tree, and that's what it looks like. So I could probably finish the lecture here. That's it. That's all it is. And all it is that I have a way to make sure if I've got some data, I can hash it all together, and I can produce a single hash for all that data, and I stick it on a blockchain in a block with a hash, and I tell that block where the previous one was and what the next one will be, and so it can't change. It's fixed in there. I cannot change any of the data. It's trustworthy now because it's now on a chain. Once I create the first block, then all the other blocks are all linked to that first block. So blockchain is really a Merkle tree. It's a Merkle tree, and that's its core. It's trustworthy in that we can't change it. That causes us problems because the last thing that you should do is to be storing anything on the blockchain that is sensitive. Because if it's a permissionless blockchain, does anybody know what permissionless blockchain would mean? Anybody can access it, it's public. So we have permissionless, which is Ethereum and Bitcoin, which are public, and we have permissioned blockchain, the Hyperledger and so on. Those are blockchains that run in a private environment, and you've got to have permissions to actually use them. So many of the banks are looking at permissioned blockchain, and you can create an internal infrastructure. So blockchain is really just all about that. It's easy for me to check that something is in there on my transactions, and everything, when it boils down to it, is a transaction. Everything I do in my computer is a transaction. If I record all the transactions, I can play them all back. In a blockchain world, if I have 1 million nodes which have a copy of the blockchain, I can kill every one of those nodes, and as long as one node still exists, I can replicate back my whole data infrastructure. So in terms of fault tolerance, we've built a centralized world. Our web services are centralized, our data is centralized. In a blockchain world, everything is distributed, and everybody has a copy, and it doesn't hide behind firewalls and so on. So that's the core, and the core is the Merkle tree. So in just 9 years, this thing has taken off more than we could ever expect anything to have such an impact on our future world. And it was started by this guy here. Who's that? Satoshi Nakamoto. It isn't him, by the way. That's what people think is Satoshi Nakamoto. Nobody has produced the key, the private key of the first block yet. There are some people who have been pinpointed at producing the 8th record and say that they are Satoshi Nakamoto, but nobody has done it. Maybe they just left. Maybe they said, we don't want to profit. We don't like the banking infrastructure that we have. Let's run this and not do it for profit. And do you know who he is? That's Hal Finney, dear departed now. If you look at a lot of the early work around Bitcoin, it's his name that's on a lot of the emails between Satoshi Nakamoto and himself, discussing running on Windows machines, running XP. If you look at the original emails, he was running version 1.0 on Windows XP machine. I mean, imagine these days running anything on a Windows XP machine. But Hal was part of the interaction, and some would say that Hal was Satoshi, Nakamoto, but he would have to have been sending emails to himself for that to actually happen. And they created the very first block. So this is the Genesis block here. Its total output was 50 bitcoins. Its reward for the mining process was 50 bitcoins. Anybody any idea how much that would be worth now? 6,000? Much more? 200,000, yeah. So it's about, do anybody know the price? 151,000 in terms of 4K times 50. Is it 600?
No, I said 50 Bitcoin to
50 to 4K. 4K, yeah. Dollars are much the same. So this is my wallet here. Okay, I was going to show you it on the screen, but I'll get you some. So in here I have zero bitcoins, I can assure you. So I can go in there and it'll ask me for a hexadecimal address. So if you give me your hexadecimal address, then I would type that hexadecimal address. That's not going to happen, of course. You're going to send me a QR code or something like that, or if you're a cyber criminal.
Why is it hexadecimal if it's not base?
I'll explain. It's a 256-bit key of elliptic curve. I'll explain it. It's elliptic curve. I have my own private key in here. That's all I have in my wallet. We get many people contacting us saying, my bitcoins are in here. Can you get them for me? They're not there. They are. Somebody stole them. Can you find them? Somebody stole your private key. And it all happens on the ledger. No, I've got some bitcoins in here. Can you hear them? and all you've got is a private key. All that happens is that somebody creates a private key for you, hopefully in a trustworthy way. There was a hack recently, I think it was Neo, that they produced the random number for you, but they kept a copy. They created their own GitHub, for goodness sake, and they paid for adverts on Google. If you wanted to get this cryptocurrency, you had to use their GitHub code. Unfortunately, they took a copy of every random number that they generated, and they could then transfer. I think they ended up with many hundreds of thousands of dollars. But watch that. If you don't trust your wallet creation, if somebody's creating a copy of your private key, you're in trouble. Does anybody know how you back up your key? What's the best advice? Would you advise me to have my key on here? No. What would you advise? USB would be very good, yeah. A paper. Paper wallet. Paper wallet, you get 13 words. Those 13 words generate exactly your 256-bit key. Anybody in your family who gets access to that, I mean, that's a good thing, because you don't want to happen what happened recently, where the person died, and you couldn't get access to their keys anymore, so you'd end up using Hashcat to be able to crack the wallet and so on. So the key is actually on there, and that was the original one there, and that happened in 2009, in January, 3rd of January 2009. That block appeared, and there wasn't any previous blocks, so there's nothing to refer back to. But all the blocks since then have got previous block and the next block, and so that we know. On here we see a hash, and there's the Merkle root. That's the root of our Merkle tree. And basically, it was a hodgepodge of crypto. It was a bit of elliptic curve, and it was a bit of other crypto methods. And they had put it all together from there. And it's grown from there to be many gigabytes. So if you want to run a node, you need to have at least 200, 300 gig on your computer, and it will replicate all of the block for you. So that was the paper there, and it's a really good read. It is a very interesting paper. Do not read the Ethereum paper, the yellow paper. It's a PDF that looks yellow, so it's a yellow paper. It's horrible, not a good read. This is an excellent read and lays out exactly his vision, and his vision is exactly what's happened. It talks about Merkle trees and digital signatures and elliptic curve and so on. They kind of picked all the right things, and it's never really needed much changing. And it was these guys here who did it, and these guys here who provided the foundation. So this is Revest, Alderman and Shamir, RSA. They kind of took their ideas of public key encryption, as we found out, and used the private key to sign, and that's the core of what they built. But it was these guys who actually created them. And then it was this guy here who took the credit. He didn't want the credit. And the strange thing is that this guy here, he is really Satoshi Nakamoto, stayed within a few blocks of Hal Finney. And it's almost as if they opened up the telephone book and found the name, and they said that's who it will be. Unfortunately, he's been hounded by the press for many years, but it isn't actually him that created it. But some other people say that it was them too. So this is a real tweet from Donald there. So the failing financial system has disgraced the American people for years, which is why I gave you Bitcoin. I am Satoshi Nakamoto. Change the financial laws now in favor of Bitcoin. But the one thing to notice here is that was sent, I don't know if you can actually see it, on the 1st of April. So it was a spoof email. So nobody actually knows who it was. In terms of the most profitable crime in the world, it's something that really quite interests me, and we're all interested in it. What would be the perfect crime? Perfect crime is to get away with it and to make the maximum of money. That's perfect crime. And when it comes to Bitcoin and cryptocurrency stealing, you have the almost perfect crime. You have virtually no chance of ever being caught. For one, law enforcement would have no idea how to investigate missing Bitcoins. Where are they? Show me them. How did you lose your key? Have you got logs? And so on. So it's one of the most profitable crimes that you can actually get. And the chances of being caught are low. Mt. Gox was hacked. They lost their things at ICOs. There's a 15% overhead in some ICOs about hacks. So when you go live with that, with an initial coin offering, expect 10 to 15% to be lost crypto through a hack. The standard way the hack happens is that just 5 or 10 minutes before, they hack the administrator and get their account, and then look at the database of all the people who have subscribed for the ICO. And 5 minutes before the offering, they send out an email saying, we're good to go, please send your cryptocurrency to this address. And they don't check, they click on the link, they send the money, and the money has gone to the wrong place. Standard thing again and again, and nobody really checks for these things. What they're looking for is that. So the scanning will look for wallet.dat or wallet.zip or some backup of your wallet, because your wallet contains the private key for your cryptocurrency. And this is a scan here of a real site, and everything here is searching for that wallet.dat. So the cyber criminal will search your Android device for that file, or search on your computer. There's a very good chance that you've stored it online somewhere. And this was an example here of somebody who detected that. They were running an Ethereum node, and then they can actually see the scanner coming in and looking for wallets. And this was the case of the hack here, that they managed to get some currency. So we really need to question our future, and in this 21st century we need to define what it is to own something. So I own this phone, but how do I prove that I own this phone? So in the future you will have a crypto token, and it will be signed by whoever created the phone that I now own the phone. I prove to you that I own it because I can sign for it. I have the private key that is publicly available to anybody that that phone belongs to me. We also need to define that ownership. How do I know I own that car? I send away a green piece of paper to the DVLC, and in between the time I send it and they receive it, who actually owns the car? And then I forget about it, and do I know that it's been transferred, and so on. So the future is likely to involve digital signing. And what's consent in a modern world? Why do we have physical borders anymore? Because most of the time you're conforming with Californian laws or with some laws from another country. So do physical borders really exist these days? Whose laws do you comply with? If I'm based in Liechtenstein, can I trade cryptocurrency and be legal? And I still do my business in the UK or the US? So really the laws of the world have been created for each nation. And one thing that needs to happen with cryptocurrency and digital signing is there needs to be much more regulation involved. And then, why does money exist? I have no cash. I don't carry cash anymore. I find it very strange to have to hand over cash. Everything I do is electronic. So why does fiat currency exist? It's existed for hundreds of years because it's a way of countries controlling their economy and generating wealth and so on. So fiat currency as a concept really needs to be questioned. And then finally, what rights do you have to privacy? And the naiveness in this area is they just pinpoint Bitcoin again and again and again. Bitcoin is a very bad example of a blockchain infrastructure. That is first generation blockchain or Merkle tree or distributed ledger, call it what you want. It has high transaction fees. You've got to pay for people to do work for you, the miners. And it's very expensive because you create competition. If somebody controls the network, even for 10 seconds, they can define that they now receive all the transactions. So we've got to avoid the concept of somebody taking over our cryptocurrency world, and it happened recently. There's a 51% attack. If you can take over all of the processing of the network and gain 51%, you create a consensus, and what you say is correct for the transactions. So that was the first one, and we're now consuming the same amount of energy as the island of Ireland, purely to run GPUs across the world and to do the hashing. So it's a really bad system, but it's worked. The transaction times are terrible. How long does it take? If I made a payment just now to buy a Starbucks coffee, how long would it take for Bitcoin network to process my payment? How long? Say again? No.
10 minutes.
10 minutes. It takes 10 minutes, so I'm going to have to wait. Visa, pretty quickly, I think. Apple Pay, no problem. 10 minutes. And I might miss the train. Maybe that block that's been created is too busy, and I've got to wait 20 minutes or 30 minutes. So it's not fast, and it doesn't scale well. It's only scaled to a certain amount, and it hasn't scaled anymore. So the second generation came along, and that created smart contracts. With Ethereum, we could actually create code on the blockchain that could run as bytecode, and we could actually trust it. And then the third generation is here, and that's looking at these DAGs. IOTA is one example of that, and it's instant consensus. There's no 10-minute waits. The network agrees straight away. So in IoT networks and massive networks, then you're looking at these types of networks that don't need to pay miners fees for their transaction counts, and they're highly scalable. And this is what they're all chasing. They're all chasing Visa. So Visa is well trusted. It can transact massive amounts of payments. But Bitcoin and Ethereum are down here. Even PayPal can't compete with Visa's rates. But there's a new kid on the block, and that's Ripple. And Ripple isn't actually a blockchain technology. Ripple is an instant consensus that if I send you some money, within 5 seconds we can agree. So it's used extensively by banks to transfer money across international borders and for the consensus to be done quickly. And SWIFT know that this could be the way forward. So SWIFT controls the financial network and the transactions, and they dismissed Ripple because it isn't quite blockchain. Does anybody know who they went for? This R3 Corda is their method that is being used. So SWIFT is now looking at that to replace their existing flawed method. So that's where we are. And basically what happens is that we have our traditional model that we're all quite happy with, that we have Bank A and Bank B. I deal with Bank A, and Alice deals with Bank B. And then we have this crazy thing to do with bank IDs and sort codes and CVV2 numbers and so on. They're just numbers. They're just identifiers. So I promise to pay Alice so much money, $10 in this case. I give her account ID and sort code. And almost like it was 50 years ago, someone checks that, and then there's a double ledger somewhere that in my bank I'm down $10, and in her bank she's up $10. So that double ledger, at the end of the day, we tally up and no money has gone missing. But as we know, fraud happens. And fraud happens because the fraudster knows after 30 days, you check your Visa statement and you find I didn't make that payment because it takes time to clear. What's the typical clearing time for a check or for money? Couple of days, 3 days. What's it doing? Is it a pony or something like that? Does it go around the world on a trip? What takes 3 days to clear? And in a blockchain cryptocurrency world, there is no need for banks in between. And Bob can transfer something to Alice without getting anyone involved. So Bob just has to commit the payment and then find out what Alice's ID is. He then makes the payment onto the blockchain, the transaction, and signs it with his private key. A whole lot of trusted miners then go ahead and try to agree that that was a valid payment. So what problems can happen between Bob and Alice in terms of this payment? Should it go ahead? Should we accept it? Should it go onto the blockchain? What decision would you make initially to make sure that it could go ahead? what happens every time you make a payment in the background that you don't see. So you go in and you buy this new speedboat. What's going to happen at the back end? Yeah, so there's going to be a check, quick check, that I have enough money in my account to pay for that speedboat. So the blockchain and the miners must check that Bob has enough money in. So basically the miners go back the whole history and look at all the payments that he makes and say he's up 3 bitcoins and he's paying 10 and don't allow it. We also need to make sure what else could happen here. I go and buy a speedboat, and then I go next door and buy another speedboat quickly before the other transaction happens. So I've got to watch now that the time between the checking and me making the payments, there hasn't been a double spend on the money. So what's going to happen is that we're going to have to go back to Alice and say, look, Bob already spent that money and we didn't check. So we have this problem about the double payments and so it was created by Satoshi and it doesn't require any central bank, although central banks are getting in on the act. So you'll find that a lot of the central banks in the world, do you know who's going to be the biggest central bank in the world? This is a scary thought. Who do you think within the next few years will be the biggest central bank in the world? Facebook. Facebook, does that not scare you like anything? Facebook could become the biggest central bank in the world because they're going to release their cryptocurrency. So you'd be dealing with Facebook coins when you buy your Amazon package. It makes sense because you buy 10 Facebook coins and you buy a book for 3 Facebook coins. If you get hacked, you don't get hacked for 10 Facebook coins. You're not exposing your credit card details. It's a tokenized world. But the scary thing is, what's the scary thing in this? So the concept, Facebook stick a lot of money in the bank, fiat currency to cover a good part so that if everybody cashed out their Facebook tokens, they'd be able to cover it. What's the biggest flaw in Facebook becoming the biggest central bank in the world?
It's not regulated. Like it doesn't have like the savings and interest or any kind of backing.
It could be, because it is locked to the dollar and any fiat currencies. So Facebook have said that if you buy one Facebook coin, it'll be worth $1, and we will underwrite that in the way any central bank does. So that it'll be regulated, and it will run, and people will know they can cash in and cash out any time and know exactly the value. So keep the HMRC happy.
So the other thing is then like the audience is privacy.
Oh, yeah.
Every
So that.
single thing you purchase is now
Yeah.
collected with all
Yeah.
your other social media.
Yeah, that's it. So now Facebook can put an advert in front of you and then find out 2 weeks later that you go ahead and buy something. That incentivizes, and now they have the last part of the chain of all your data, what you actually buy. Google tried to do it. They bought some, I think it was Visa details. So they wanted that. They were involved in a research project that said, let's see if we feed you adverts, if you go ahead, if we feed you a Ford advert in 2 weeks' time, if you go and buy a Ford car, then we're going to get a lot more money back from the advertiser because we've linked you together with your purchase. So that's a scary thought, but we could see that. So with this, we create and we go to 8 decimal places for our cryptocurrency, and 1.000 is a Satoshi in there. So that's the smallest amount of the currency that we can actually get, and everything's represented as an integer value. It was always decided that we would have a finite amount of currency. So you'll all be millionaires today in the lab, I can assure you. you'll all be crypto millionaires because you'll create your own Genesis records, your own Genesis record, and you'll give yourself cryptocurrency, and you can't recreate it. It's there, and it's finite. To be able to create a new cryptocurrency or more cryptocurrency, you need to fork, and you need to decide that that is finished, and we now fork and we create a new blockchain, and we release more money. So it did happen with Ethereum. Ethereum got hacked, and they had the decision, and it's a scary decision. Should we just turn the clock back? Should we just say that let's have a Groundhog Day, and that let's take all the transactions that happened over the last day, which includes the hack, and take it back to yesterday? If you do that, trust goes out the window. So it means that anybody who controls Bitcoin could always roll back. They don't like the new payments, they'll roll back. So what Ethereum did was they had Ethereum Classic, which continued, and they had new Ethereum, which was a fork of the original blockchain. So the reward reduces over time because you want to stop the mining from happening. So to incentivize the mining, then you pay, it was 50, every so often it halves, and I think it's down at 12.5 Bitcoins. It's just enough to keep the miners happy. But very soon, miners will go out of business. NVIDIA won't make as big a profit anymore. So the GPU manufacturers have been making stacks of profits because they're selling to the miners. Unfortunately, your computers can all be part of a Monero mining network, and you might never know about it. It happened recently for that. Okay, so we reduce, in this case, if it's a proof of work means that the miners have got to do something to prove that they are good miners, and it's going to be too costly for somebody to hack 51% of the network, because you would just have to buy too many GPUs and take over the infrastructure. But it has happened. For some of the some of the less popular ones, it can be not too difficult to take over 51% of the network. So we've got Ethereum, Ripple. You can create your own cryptocurrency today if you want, and it might not have any value, but you can create your own blockchain, and you might call it your student your student chores cryptocurrency. So there's the Genesis record there. In the Genesis record, we have the hash of it, we have the previous block, and the next block. And there has the time, and the time between this block and the next block is typically 10 minutes. The reward in this case was 50 Bitcoins, and that's 0. So there's been quite a few big flows of cryptocurrency. So this was one here for 1,200,000 Bitcoins. That's billions of dollars in an instance, in a single transaction. Imagine the stress that you would have if you've just sent $1 billion to yourself for getting that wrong. And we've got one here, massive transaction here for 2,000 Bitcoins. So there are massive flows that you can get, and you can get it to go from one person to multiple persons, or you can aggregate from a number of accounts into a single one. Okay, so this is what we see in terms of our record when we look at the address. So each account has their own hexadecimal address. That address is derived from the private key of the wallet, of the person. So we can link the private key exactly to the address that we have here. In terms of transactions, this is the flow. And that's the exponential rise, and that's the bubble burst there. So people were using this to make money. It wasn't because this was a great way to do business and transactions. People were investing in Bitcoin because they wanted to make money. And in this period here, everything was good and people were making lots of money. And it had to crash sometime. So it did crash, but then it kind of hit a bottom there. And when people were saying it's going there, it turned itself round. I don't know if you've been looking recently. It's kind of hovering around the 4K region, and it isn't doing too bad. So it looks to be stabilized in the supply and demand. If you have more supply than demand, what happens to the price? If I supply too many Bitcoins and there isn't enough demand, it goes down. And then if there's a bigger demand than the supply, then it goes up. So standard rules of economics. So just now, the transactions are sitting about 304,000 a day. And the transaction values, well, they've been quite stable to some extent. So we're seeing about 160,000 Bitcoins a day being transacted from there. There's obviously spikes that have happened as people cash in and cash out. And the value itself has went up, and it's kind of stabilized now about 4K. But it could crash tomorrow, and it can be worth 0, or it could go up to 20K, who knows? It's all to do with the supply and demand. So these are some of the currencies here. This is the top 10. In terms of like a bank or the value of the dollar, then it's not large market capitalizations. 71 billion for Bitcoin. That's for some banks. That's not a big amount in there. Ethereum is second, and the Ripple XRP is in third place. An interesting one is Monero there, that was involved with the cryptojacking on computers, because they use a distributed network rather than GPU miners from there. But there's literally thousands of these cryptocurrencies. So we'll go and we'll view them all. So we'll go right down to the bottom, see if we can find the one. There we go. So this is all the cryptocurrencies. Keep going. So these ones here are only worth about $1,000 overall. And go right past 1,000. There we are at 2,118 cryptocurrencies in there. And from your wallet, you can trade in these currencies. You can move currencies back and forward. So Bitcoin is associated with criminal activity, and it isn't anymore, because does anybody know the cryptocurrency that cyber criminals would often use these days? Monero, Zcash. Does anybody any idea why they would use those ones? What was it? They're almost zero traceability. I'll explain that later on. So with Bitcoin, you can see exactly the transactions that are involved, and you can actually trace people to their identity. So let's have a look at the address. And this is the magic. So you might not get this straight away, but this is just sheer genius, the way that this all works. So what we start with is a 256-bit elliptic curve random number in there. That's your key, and you should not release that to anyone. We then converted to base 58. Don't ask me why it's base 58. What do we normally deal with? Base 64. So why do we use base 58? Does anybody know that? Like if you're asked us on Who Wants to Be a Millionaire, why we use base 58 rather than base 64? Because the L's and the I's and the O's, all the ones that we struggle with aren't there. So they've dropped off about 6 characters or so, and that's what we end up with. So this is the key that we store in our wallet. Okay, it's called a WIF key, a WIF private key. And if you looked on my machine here, if I had any bitcoins, I would be storing that in my wallet. When somebody steals my bitcoins, they grab that. Then what happens, and the magic happens here. So elliptic curve, remember what we do, we take the point and we multiply it so many times by this number here, and we end up with a public key value. So that's standard elliptic curve. It's a 512-bit value, which is our public key almost. It then goes through a few hashing, and then we end up with our public key. So when somebody, our public key ID, when somebody wants to send us some bitcoins, we send them that address, usually as a QR code, say, and they'll send the money to that address and put it onto the Bitcoin. The amazing thing about this is that I can sign a transaction with my private key and I don't have to show you my public key. It's all inherent in what goes on here, and I'll explain that at the very end. So it's not like PKI that I have to show you my digital certificate to the world and say, look, I signed that. You don't have to go to a PKI server and check the certificates and the signer. I put that onto the public blockchain, and you can tell it was me that signed it because of the magic of this process here. Okay, so that's what a transaction looks like. That's what your account looks like. Okay, so there's the address being made there. Typically, you'll see a 1 at the start. That's how you identify a Bitcoin address or a 5. Okay, so there's a private key, public key, the WIF key, base 58, and then that is the address that you create as your public address. I then sign for a transaction and end up with something like that, and that takes my private key from there, and automatically somebody knows that I've signed that correctly without me having to show the public key to anybody. So it might seem it's a crazy thing, but it works, and I'll explain how it works at the end. Okay, so that's what a transaction looks like. There is a previous hash for a transaction. We create our signature with a private key, and we integrate the public key onto that signature automatically, and then we can put that onto the blockchain. We take the public ID of Bob and we add that onto the transaction, and that's how it works. Then we have our miners that go ahead and pick up these transactions and try to make sense of whether it's valid or not. So the blockchain itself is made up of these blocks. Each block has a number of transactions in it, and these are the transactions that the miners have agreed to and to put in there. At the end of each block, the miners must race to produce the required hash. So the hash itself is a challenge that requires some sort of computational expense, and they race to be able to become the first to produce the hash, and then they get a reward from that. So in terms of the current miners, the last thing we want to do is gather 51%. So if one organization takes over more than 50% of the network, they can control the whole mining process for that amount of time. So in terms of the current mining, you can see that a large majority of the successful miners are actually dominated by just a few companies. So they're investing millions. They're in places that have cheap electricity. There was a case, I won't say what it was, but there was a mining company who had an electrical supply, and these criminals came along and tapped into their power supply and were able to run massive GPU infrastructures. So the profitability is to do with the amount of money it costs you in energy to run your GPU. If you've ever run a GPU on your computer, you know it's very hungry. If you run millions of these GPUs, it's going to cost you a lot of money for that. So that's the current thing. And what happens is that the hash rate keeps increasing. So the difficulty in creating the hash increases over time, which makes it more and more difficult for the mining process to happen and more expensive. So more of the miners drop off as less and less currency is available. And what they do is that they must find a nonce value that when added to all the valid transactions, you come up with a hash value which is a certain number of leading zeros. And it's not easy. So they've got to keep trying random numbers and check to see if they have, say, 11 zeros at the start. And whoever wins that, they tell the rest of the miners that they found the correct hash, and then they will be rewarded with a number of bitcoins. So we see that here. It's difficult to see it, but there's the hash that's been produced. And look, it has lots of zeros at the start, and the miner has been able to find that one. In this case, it was Antpool that managed to get this one, and the size of the so this is the block numbers there. The size is only 1 megabyte. You got to imagine this was 9 years ago, and 1 megabyte seemed a lot of space. You're never going to need any more than 1 megabyte. But we've filled that up, so we can only get 1 megabyte in every block in 10 minutes. So if you don't manage to get your transaction into that block, you're going to have to wait for the next train. And it's been the case that people have had to wait 2 or 3 blocks or more to get the transaction onto the blockchain. Okay, so it was 12.5 bitcoins was the reward for that one. But then Ethereum came along, and Ethereum's interesting because it brings in smart contracts. I don't know if that's going to go. And it gives you the concept of having contracts that run off the blockchain with trusted code. So why do you need to be running DLLs and have APIs that are Facebook APIs, and you have to call those things up? Why can't we have smart contracts that we agree to, a contract, and we define that's the contract? If I provide you with this, you will pay me some money, and we can actually define what the contract is. So everything was going well with Ethereum, and then CryptoKitties came along. And CryptoKitties was the first application of the blockchain which started to build a whole ecosystem for payments. And it makes sense because in a game, you buy credits and you buy things. So why can't you be running blockchain infrastructure and buy and sell things with digital assets? So we buy physical assets. Why can't we buy virtual assets? They are a piece of art. They are a real thing. So with CryptoKitties, you could actually buy your cats. And unbelievable, I think $100,000. I can't remember how much they were bought for, but somebody paid a lot of money for one of these things here. But it's yours, and nobody else has it, and it evolves over time. This one here, just doesn't look in a fit state there. So you go online and you buy your CryptoKitties, and then you can sell them on. There's another one's there. The problem with CryptoKitties is that it caused a bottleneck on the Ethereum network. So there was a spike here when CryptoKitties really took off. And people thought that was it. It's hit its limit. It can't go any faster. We've shown that just running one application, CryptoKitties, has burst it. The good thing is that we have people like Vitalik who are looking at new models of Ethereum. And generally, we've been looking at new ways to scale the transactions, and it's increased in the throughput as more and more companies put their applications onto it. So Ethereum was created by the genius that is Vitalik. So you've got to listen to him and read his blogs and so on, because really what he lays out is a future world that is completely distributed and trusted. Not one transaction can go missing. If I wanted to audit a whole bank at this second in time, I can. And I can go back 1 year and I can see all of the transactions. I can audit for the whole of the UK banking infrastructure for every single payment that's ever happened. It's impossible to have fraud in that model because every transaction is traceable to something. So he created the concept of smart contracts, and unfortunately it was hacked and it split into two, Ethereum and Ethereum Classic. And then what it did was that it did the same thing. We had our transactions, and then we had our block hash, and the nodes created SHA-3 hash for it. But now they were paid for the amount of work that they did. So rather than getting 12.5 bitcoins for winning, each miner had existed in a fairer world. So for the amount of work that they did in producing the hash and processing the transaction, they would be paid in Ether. So the more work they did, the more Ether they would get, and it's an advantage for people to be putting their miners into the network. So in Ethereum, we have the concept of miners being paid for the work that they do. But they're not going to get out of bed if you're going to say, well, here's a transaction, and I'm only going to pay you a small amount. So there's a trade-off when you advertise your work and saying, here's what I'd like to offer you, and the miners will be attracted to that transaction because it has a high value. But the miners themselves will always pay back the money that they haven't used up. So although you might advertise for a certain amount of Ether to run your smart contract, you might be overinflating it, but the miner will only charge you for what you've actually created. So we'll find today in the lab, you try to do anything, and if you don't have enough cryptocurrency in your account, you won't be able to do your smart contract because the miners won't want to do it. So we define a basic payment called gas. And the gas relates to the amount of work that we do, the size of the hash, the amount of code. And it's there to stop developers from being inefficient in creating verbose code. The more verbose your code, if you have an infinite loop in your code, you're going to have to spend a lot of money because the miners will quite happily run away with that code. So it's there to be as efficient as possible for both the data and also for the transactions. Okay, so it's that payment happens, and again, as I said, if the transaction fee is set too high, then there's lots of eager miners wanting to do the work, and they'll probably prioritize. So as we'll see today, when we create our smart contract, we define a gas value. That's the reward that a miner will get if it undertakes our contract. But they do return back the excess gas. So though we define a payment, if they don't use it all up, then they won't overcharge for the work that they've actually done. Okay, and then we get the concept of running smart contracts. So in Ethereum, what we can have is a smart contract that runs trusted code off the blockchain. So both Bob and Alice agree to a contract. Maybe it's a marriage contract. So they will say that when Bob gets married to Alice, Bob provides something there, and if Alice provides something there, then we can now say that they're married. And that's the contract that they would define between themselves. This contract itself is typically written in a JavaScript type language using Solidity. So today in the lab, we'll be using an online Solidity compiler and also an offline one. But this will compile our code into a binary format. And it's this binary code, just in the same way that Java runs in our trusted environment, it is this binary code which runs off the blockchain there. So this is one way we can do it. We can go online to this website here. We then compile to a certain version of the smart contract compiler for Solidity, and it creates this little bit of code here. This is what's called a Web3 deployment, and we basically create a little JavaScript program that will run on our blockchain and integrate the binary code into it. So this is what a future world could look like, in that people could get attestations that they have certain things, in this case that Bob has type 2 diabetes. And then these attestations would then run off smart contracts, and then you would get automatic payments or discounts in this place from the NHS. So when Bob goes into the NHS, into Boots, he's proven that he has diabetes, and he might get a 10% discount on his medicine. So in this way, we create a much more efficient world. So what we'll do is we'll have a break for just 5 minutes, and then I'll do some blockchain crypto, and then we'll have our little test. Okay, thank you. Good. Okay, so let's look at some crypto that's happening on the blockchain. So the major problem that we have is the scalability issue of blockchain, and also that nothing is anonymized on the blockchain. So if we're going to build systems for the future, we need to make sure that the blockchain itself doesn't actually have any data on it that can reveal individuals. So that's a challenge that we basically have. So this was one model. So we've all seen the 7-layer model for networking, the OSI model that we always go with. This was one that I saw that I thought was quite interesting. I mean, it's nothing's happened with it, but I think this is an interesting model of how we could build systems of the future. At the top, we have our finance and our governance and our accounting and our rights. So we kind of fit in really around here. We build systems, we integrate Active Directory and rights and stuff like that. So we kind of do this technical infrastructure in there, but that should all build up into finance systems and healthcare systems and so on. But have a look down here. Look, it's cryptography that provides the lowest layer. In the same way that Ethernet provides our networks as our core on physical cables. To a certain extent, copper cables and fiber provide our backbone to all the stuff we do on the web. We need to make sure that that's trustworthy. So our future could be really built on this strong cryptographic mathematical infrastructure which is provable. Every little transaction can be proved because it has strong cryptography. And we use good software engineering to be able to build these systems and not just pull them all together, and so that all our APIs can actually integrate. So the core, as I said, of blockchain is around the Merkle tree, to make sure that all our transactions are then defined as a hash and provable within each block onto the blockchain. And then once we've started our genesis block, we can then trace, and it's immutable. You can't change it. It is defined exactly, and it gives a true state of the truth. So why do we build SQL databases and structure and things like that? Why can't we just have a whole lot of transactions that we just run and we know exactly what the system is? So this could be the future, in that we have blockchain and there's an anonymized layer underneath. And we use Zcash or Monero or even a method called Mimblewimble to be able to anonymize everything onto the blockchain. So you can't tell who sent and who received it and what the payment was at all. But layers above that, such as anti-money laundering and healthcare, would be able to reveal the identities that were required. Sometimes the citizen might own that scrambler, so that only by the citizen revealing to the HMRC will they be able to reveal all their transactions. Sometimes it will be the bank that will keep all these secret things, that if they're asked by the payments that Bob has made, they'll reveal all this thing that will resolve Bob back onto the blockchain. Okay, so that's the system that we have. We sign with a private key, and that integrates our public key. The way it works is, or it used to work with Bitcoin, is with what's called elliptic curve DSA. And this is the way that we could actually sign something onto the blockchain. It creates two values called R and S. And you'll find in a blockchain transaction there is a value for R and a value for S. With those two values, you can actually verify that the person has the right private key for the signature that is for the transaction that's just been signed for. So this gets away from having a PKI infrastructure and digital signatures. These R and S values automatically verify that this person has that private key for that public ID. You probably don't see it straight away, but it's magic. And the biggest problem with PKI is certificates and all that trust thing that doesn't quite work, and revocation and all that kind of thing. So it's that signature there that does it. But unfortunately, that has caused problems. And it causes problems, and just let me get this to show correctly. If I can just exit that, that should have shown something else. Let me add that. To move. So I want build in, add a fit, move in. And the problem that was being caused is for a transaction such as this. So this is a single transaction, and that's taking lots of people's, that's transferring from lots of people's accounts into these accounts. And with the previous blockchain or Bitcoin, you had to check each of the public keys or each of the signatures on this transaction to make sure that that works. And it was filling up masses of space on the public blockchain. And also the processing of this was becoming unmanageable. So they did a consensus. So everybody's got to agree. So the code is in GitHub, and there are trusted people to look after the code. And then they had to get all the miners to agree that they would change over the method. So they moved from ECDSA to Schnorr. And Schnorr is defined as multi-sig. And it's an amazing little method because I can have any number of signers and I can merge them into a single signature. And then I don't have to check each of the public keys. I can trust that all these people have actually signed the transaction. So this is what basically happens, is that each of the signers reveal their public key. We then aggregate it together, and we end up with a single public key which signs the transaction, which means that all of these people here have actually agreed, and we just need to check that one public key, and we know that they've all signed it. And the great thing is we can now hide each of the IDs of the senders behind it with a single key. So it happened then. So this was the changeover to use the new signature method. And it shows that it is possible for the whole of the Bitcoin community to get together and agree on a fork or a new update. And everybody agreed, and this was the new block that was produced with the Schnorr signature built into it. The other thing that people are working on, Monero have always been at the forefront, is Zcash. They've always wanted to anonymize everything to do with the transaction. And what Monero have done is create what's called a ring signature. So a ring signature involves, so Donald Trump knows that one of his staff has signed a message, but he can't tell which one it was. So by taking all of their public keys together, they have found some way to sign a message, and it's trustworthy to know that at least one of them actually signed it, but he can't tell exactly which one it was. And the advantage with this is that if I get together a whole lot of people that has the same transactions as me, and I use their public keys, then I can now hide. So I take all their public keys, I add in my public key in some way, and I can sign for that group, but nobody can tell that it was me that actually signed it. And that's the way that Monero generally works. We create a ring signature. Bob, who's the one who's signing it, actually applies his private key into it. The signature goes round, and we actually produce an output and sign for the message, but it's impossible to know that it was actually Bob who signed the message. And also what Monero creates is what's called a stealth address. So I now want to hide that the transaction is going to Victor. What I create is that I do an exchange with Victor, and Victor creates a new stealth address, which is a new ID that he has. The money will be transferred to that ID, which has just existed on the network. And the money goes there. Victor knows how to get the money, so then we'll transfer the money into his own account. And because of the ring signatures, nobody can see that the money is going from his account, from that ID into his account. So stealth addresses hide the recipient of the transaction. And if you're interested, that's the way the exchange does, but it's just standard elliptic curve. Okay, so that's been an outline of a blockchain. You'll have the opportunity today to do some coding, create your own blockchain. You'll probably muck it up and start again, but it's under your control. It's the first time we've run it in our virtual environment for every student running their own blockchain. So if it falls over today, then fall back to Windows. We've got a tutorial on it from there. Does anybody have any questions on what we've done at all? Appreciate there's a lot in there, but hopefully some of it is useful. So just let me see if I can get this to work from there. I don't know why that's not working. Okay, let me go to here and let me run my quiz. Okay, let's see. And I think it's blockchain. Good. So let me find it. It's that one. Okay, so go ahead and if you could just connect to there, we'll see what you think of cryptocurrencies and payments. So I use Android Pay. It's Google Pay actually. I used to love Apple Pay because it had a biometric on it. I really trusted it greatly. So we've got some cash, which is good. There, contactless, very popular. In the vending machines here, who uses cash for the vending machines? Who uses contactless? Is it just me? No. And who uses their phone? You do know you can use your phone for the vending machine. It works really well if you enable it. Quite like it. Okay, so there's no love for Android Pay. Wonder why? For some reason, Google haven't integrated the biometrics into it. So we're still mainly cash and contactless. We need that bit of plastic in our pockets to exist. Who, when they get on an Edinburgh bus, uses money? Good. Who uses the scratch cards? Does anybody use them? I know people who use them. I can't understand it, but scratch cards. And who uses the app with the number? Yeah, I use that all the time. And the rest of you don't get the bus. Okay, so it's interesting that contactless is the one that's the most popular there. So what's your trust in cryptocurrencies? Do you have high trust in cryptocurrencies? Medium, low, very low? Do you trust Bitcoin? Would you trust it to hold all your money, do your transactions for you? In Switzerland, you can buy. I've been to Zug, Crypto Valley, and there are bars that you can. I don't know how you would do it. Like this beer is worth 0.001 Satoshis or something. Just talk to me in Swiss francs. Okay, so nobody has high, so that's worrying. Medium, you're all in that bit. And who's got very low? Have they been hacked? Have you been hacked? No. Why is it very low? You just don't like it. Doesn't make sense. Good. Okay then. Hopefully by the end of the module, you'll probably be very, very low at the end of the modules. once we've looked at it, especially the last bit of crypto there. So that's interesting. If you were to buy cryptocurrency, if I gave you $1,000 to go and buy some cryptocurrency, what do you think you would buy? Yeah, so we've got a lot of love for Bitcoin, not so much for Ripple. The guy was one of the guy who, XRP is the cryptocurrency. They are not linked together. Okay, XRP is a way to fund the whole Ripple infrastructure, and it's a coin. Ripple is a protocol for the transfer of money. So there's a lot of love for Bitcoin and Ethereum, and a little bit of Litecoin. And would you give your CPU for free for a crypto miner? No. Oh, depends on the service. Good for you. So if they let you run a game for free and you used your GPU for a little bit of time, that sounds okay. If you get 10% off in Starbucks and they'll mine your computer, then maybe that's acceptable. There is nothing wrong with it. Unfortunately, the first JavaScript implementation ran away with your CPU. So you went to Starbucks and your CPU went massive. They should have throttled it back from there. So it is a perfectly valid model to give away because your computer sits at 1% CPU all the time. It does nothing. You're wasting resources and it's not actually doing any processing. So perhaps it's acceptable from them. So do you believe that cryptocurrencies are used mainly by criminals? Cryptocurrencies free people from banks. Cryptocurrencies are mainly for hiding their tax returns. Cryptocurrencies will never take off, or cryptocurrencies are a faster way of doing transactions. So we kind of got it's kind of across the board, this one. This should be interesting from there. But yeah, there's a lot of love for faster payments and freeing people from the banks there. But quite a few people just don't think it's ever going to take off in there. And quite a few people think that it's for people to hide. And not so many for cyber criminals. That's interesting. I'm sure if we did this with the general public, that one would be top there. Why do you use Tor? Because it's privacy and so that's interesting. So cryptocurrencies are the future, a bubble that will burst, never going to match our existing finance infrastructure, or are actually a risk for the future. What do you think? The future? Aha, good. But we've got a few that they're quite worried about the cryptocurrency world in there. Quite a significant amount. Few that say it will burst as a bubble, but at least half of you are saying that it's the future of thing. Don't swear here. Just give me a word that describes cryptocurrencies. If we can find this area. Crypto, there you go, that's a quick one. Sophisticated, oh, that's very good. Not complicated. Millionaire, drugs, dank, smashing, encrypted, safe, good. I don't know what the light one there says. Yeah, buzzword, good for you. That's exactly right. Stop people using the buzzwords. And scary, hashing. Millionaire. So who's a millionaire? Yeah. Good. Drugs. Scary. Safe. A lot going on in there. Okay. So get yourself registered. We'll have our usual little quiz. See who can win it this week. Okay. Yeah. That's it. Yeah. You're getting there. Okay. Everybody registered. Okay. Don't swear. Okay. There we go. Okay, so I think we're good to go, hopefully. That doesn't look good. I didn't actually see this, but who was one of the cyberpunks? I should have said this. Sorry about that. How funny Eric Hughes, Ron Rivest, or Tim Berners-Lee? I didn't say it. That maybe give you a little bit clue. There was 3 of them. They appeared on the front page of Time magazine. They were the cyberpunks, and it was Eric Hughes. I appreciate I outlined how funny but it was actually Eric Hughes was one of the cyberpunks who decided, and he could have been maybe Satoshi, who knows. It definitely wasn't Ron Rivest, that's for sure. Okay, so who knows that? That was really good. Casper, who's Casper? The ghost-looking person? No. Good. Puffy, good. I know what that big clock identifies. Who's the A in RSA? Leonard Adderman, Leonard Alderman, Leonard Ankerman, Larry Adderman, or Lizzie Adderman? And that's right, it was Leonard. Leonard was is the A in RSA. So the cyberpunks were inspired by RSA. They didn't adopt it. Luckily, they adopted the elliptic curve. So it's Clippy. Clippy, stop and aim in there. Okay, so for the next one, which is not a public key encryption method. RSA, elliptic curve, LGAMO, or AES. Please get this right. Good. Well, most of you got it right. So RSA, elliptic curve, and LGAMO are all public key encryption methods, or asymmetric, and AES is a symmetric key encryption method, as you should all know at this stage. So we've got should have paid attention. Good. I won't ask who that is. Oh, should have paid attention was number one. Should have paid attention. Should have paid attention to what? The lecture? Yes. All right. I know. You should have all paid attention, but you can watch it back anyway, so it doesn't matter. Okay, big clock. I know where this big clock has came from. Who co-created Ethereum? Look at your phone. Vitalik, or Vitalik. You'd have to be paying a lot of attention to this one. Oh, well done. So 10 people were listening, paying attention by that one. So that's good. So good old Vitalik. And so we have communicated with him in the past, and he's such an inspiration in this space. So we've got AIM. Should have paid attention. See, there you go. Should have paid attention to that one. You would have got that one. So for this one, which country is introducing a blockchain act? Any idea who that is? Liechtenstein, Estonia, Finland, Jersey, or the UK? I did try to create a petition in the UK to get many votes. Not like the one that's been created now, but it's not the UK, that's for sure. It's Liechtenstein, and if you can read German, go and have a read of it. It's a great read, actually. So they are laying a legal foundation for cryptocurrencies and ICOs and digital signing and so on. So we're a bit all over the place here, but it's AIM. Who's AIM?
Oh my god, it's me. I'm so excited.
What's that? It's you? Yeah. Oh. You shouldn't be surprised. You shouldn't be surprised, because you've generally went up to there. Hashberg is always in there somewhere. Should have paid attention. Should have paid attention, I think. Okay, for this next one. Bob wants to send Alice some bitcoins. Which key does he use to allow the transaction? Bob's private key, Bob's public key, Alice's private key, or Bob's public key? Or who cares? It just happens. Okay, it's Bob's private key, of course. It is. It's nothing to do with Alice. Okay, Alice does not have to get up or do anything. She's not involved a bit, but all of a sudden she sees cryptocurrency appearing. So it's Bob's private key, makes the whole thing happen. And will be Spartan Green and Corb. But AIM is still, you're still top. Yeah. There's still another 20 questions to go, so no pressure. Bob wants to send Alice some bitcoins. Which key does Alice use to prove the transaction? Bob's private key, Bob's public key, or Alice's private key or Alice's public key. Which key does she know that it's correct? It's Bob's public key. Of course, she's no keys on her side. It's purely Bob's public key. And if you listen to that last little bit of the lecture, which I know that very few of you probably did, it's all signed onto the blockchain, and she can do that proving in there. So see how we got on there. That will be, it might be struggling. Oh, you're still top. Well done. Will be is going up fast, Liam, and Concat Clippy. Okay, so look at your phone. And there, roughly, how many bits does an elliptic curve public key have? 112, 256, 512, or 1024. Okay, you would have had to pay attention to this one to get this one right. And it's 512. Your private key is 256 bits. It's a point on the elliptic curve. It's an X and a Y. It's 512. Ho ho, this is going to be interesting. Do you think you're still top? You get it wrong. You get it wrong?
I did, yeah.
Okay, right then. You might still be top because only 4 people got that one right. Ho ho, AY, AI. Who's that? Oh, well done. Yeah. So you were just biding your time there. Ho ho. That's really unfortunate. Where are you? Oh, you're second. So you're still. This is the closest I think it's been. This is really exciting, actually. Will we put some money on this one? Anybody want to put a bet on this one? I think might be. I'd put a pound on that at 5 to 1 if anybody wants to take that one. So DP is always in there, Clippy and so on. So look at your phone. Come on, AY. Is it AY? Is that how you say it? Or A? Or I? Oh, sorry, I didn't go over this at all. There's 3 types of tokens that you can have, and I didn't do this, so you just have to guess. Okay. The 3 types of tokens are a security token, a utility token, and a payment token. Payment tokens are like Bitcoin. Utility tokens is as you go on the bus, that's your utility token. And a security token is used that I own this phone. So the access one is the one that isn't right. So I apologise for that not being in there. So let's see who randomly got that one right. And it's still AY. Is it? How do you pronounce that? Yeah. AY. Is it? That's it. Oh yeah. That was cool. So I think that wasn't easy. And Liam will be in just in 4th place there. Okay, so hopefully you've taken something from that. There's a lot to cover in the test. I'll be giving you, as before, all the questions. So even though you don't get it now, you've got 6 or 7 weeks to really understand what blockchain actually means, and we'll give you some practical experience. Does anybody have any questions on what we covered? You can ask in the lab if you want. Please come along to the lab if you've got time, and we'll be millionaires for the day. Okay? You can be your own cryptocurrency millionaire. Thank you.